the Geotech and Structures Lab, our mission is to create solutions that improve our nation's defense, security, public safety, and infrastructure. And we have some of the brightest engineers, scientists, materials scientists here on our team that understand the challenges that our military and our civilian workforce face, and we deliver those solutions by partnering with industry, academia, and finding the best minds out there to solve those problems. New technologies like metal additive manufacturing at large scales are just instrumental in delivering new ways to get after these challenges that our nation faces.
So definitely utilizing additive manufacturing is really revolutionizing a lot of the operations and maintenance community within our portfolio from inland waterways and navigation systems. Say I have a failed part, I need to have that part manufactured. It can take 18 plus months a lot of times for any component, because we're talking about these really large cast infrastructure components. There's no standardization across the country for any of these components. Casting hates that kind of parts. We want to make 100 or 1,000 of something. Additive doesn't really care. I don't have the upfront tooling costs that are associated with trying to fabricate a component when I'm looking at using additive manufacturing. So additive is actually not only more efficient and really kind of push the timeline of how fast we can get parts manufactured, but it's also changed how we look at part manufacture from a materials standpoint. So there's a lot that goes into making these materials ready for defense and infrastructure applications. So for our military engineering portfolio, it's also vital because we want to be able to protect the warfighters of our nation's military. So when we're talking about some of those materials, it's high hardness values. There's a lot of work that goes into characterizing different materials. So whether we're looking at quasi-static or high rate performance, leveraging a lot of these in situ process monitoring methodologies in order to be able to capture all that data and have a good confidence. A lot of that information is coupled with thermal models, or process models as we call them, to be able to guarantee how those materials are going to perform. So the other side of that is also looking at scalability of technologies, as well as pushing these technologies as far forward as possible. And so a lot of that for ERDC application spaces is centered around bridging systems, say like railway steel, to support a lot of our force projection mission area.
Today, looking at what industry and government have pulled together in terms of these large-scale components have just totally changed the game. You know, we can get after parts in a couple of weeks now that traditionally would have taken years to work. I don't know that we can even predict the future right now on future applications, but I know that they're on the right path to bring new solutions for our nation's infrastructure. It's aging. We need new methods to maintain it. And for our military readiness and deployability, this really gives us an edge to keep our warfighter in the game.